Alex Levitz. Start this presentation with the quote from Coherence report. The business absolutely devoted to service will have only one word about profit. They will be embarrassingly large. And actually, the ON24 is all about service. We are a SaaS company. We provide software as a service and we deliver virtual events. What ON24 is, first of all, it's a global standard for webcasting and virtual events. We have over 35% market share in the webcasting industry. ON24 is not a brand new company. It's been founded in 1998 and it's currently over 250 employees, probably close to 300 right now. We have diverse customer base. 150
Excuse me, Alex, I'm sorry to interrupt you. Your phone is cutting in and out. Maybe you can adjust if you're on a headset. Thank you.
Is it better now?
Much better. Thank you.
Okay. Sorry about that. ON24, we have diverse customer base. And 80 of those customers are Fortune 1000. We have global footprint with offices and partners in Americas, in Europe, in Asia. We have unique technology with over 15 patents, and it's still a private company, but we have highly respected private investors. Next slide shows you our reach in global market leadership. So these are just logos from just a few but well-known customers that we have. And as you can see, it is in different groups, different areas of business. This slide shows you kind of lineup of products and what we do. Starting with standard webcasting, similar to what we have right now, the next level is a platform 10 webcasting. That's a platform that we provide where customers can create their own webcast with a lot more customization and where they allow for much greater user interactivity and engagement. The next would be event portals, where they can browse through a variety of already existing webcasts, listen to them, and search through the knowledge base. The next level with much higher interactivity user engagement is virtual events, similar to virtual trade shows, like an Oracle World or other similar events, but everything is done online. So there's no physical world participation. Users log in, they see a 3D interface, they can walk into a conference call, they can walk into the booth, they can chat with other users, they can get all the information you would get in a physical trade show, but you will see everything online. And we have virtual environments where specific groups of users can participate and interact in fully virtual environments. That's almost 100% user interactivity and engagement given to participants. But if you categorize this type of products that we provide, you can categorize them into three main groups. So one is this platform 10 webcasting. It is primarily used for lead generation, for training, for product launches, town hall meetings, and corporate communication. Virtual shows, those type of virtual events are mainly used, again, for virtual trade shows, user conferences, global sales kickoffs, partner trainings, expositions, and recruiting. particularly for different job events. And event portal, that is mainly used by users offline. So it's what I mean by offline, it is not for a specific time when event is happening. Users can log in at their leisure, and they can search through our database of webcasts and virtual events. So this usually used for demand generation, sales enablement, partner training, corporate learning, and webcast repositories. So all of this is happening pretty much 24/7 and all the time. So you can imagine that some webcast participants, when they're listening to their events, they're not very active, and they do not generate a lot of activity in the system. However, they do, and that is relatively like a small objects going down into a technical details. People who search through event portals, they may generate some reports, and their activity will be completely different. Users in virtual events will typically either go through exhibition halls or auditoriums, or listen to some lectures, chat with other users. So they generate variety of traffic, and variety of different activity, different size objects in our system. And at the same time, users that are operating virtual environments, they will generate variety of traffic. Typically, when some large event starts, I have seen cases when number of participants grows very rapidly, from 200 users to 20,000 users in a matter of few minutes. That's a very, very strong punch into any infrastructure. So, how we handle all this traffic? Typically, what you would do, you would have a cluster of application servers. In our case, we use WebLogic Server. We have a cluster of servers, and we have a load balancer in front of the cluster. And we host multiple applications in our WebLogic cluster. And typically, a load balancer will send traffic in round-robin fashion to every server in the cluster. Those servers are uniformly processing a variety of different transactions and different types. The challenge providing highest quality of uninterruptible service lies in a few things. First, there's such a variety of traffic hitting each individual server. It's very difficult to tune WebLogic servers for best performance and stability. The reason for it is the high levels of JVM fragmentation. Objects that are created in a JVM heap are different sizes. They have a tendency to rapidly change, and all this contributes to high fragmentation in the system, in the memory. And as a result, it ends up with long GC paths, and those paths are very hard to control. The other challenge that we face is that occasionally live traffic needs to be switched from our primary cluster into a backup. As any company, you need to do software upgrades. You need to do releases, some other reasons. So when you switch from your primary cluster into a backup cluster, the user sessions that exist in the primary cluster, they will not be replicated in your backup. So So users that were connected to primary and now in a backup, they will lose their session. This will end up in short interruption of the service. And that actually creates a major inconvenience for our 24/7 platform. We also, so to accommodate that, to somewhat resolve this problem, we had to schedule those traffic switches into some times when there is a minimal load on the system, and that would typically be somewhere in the middle of weekend or late at night, and that's actually a bit of a challenge because people who do actual switches would have to work in those off hours, and that's not convenient at all. So what's the solution? Obviously, to solve the problem number one, which is the fragmentation, we have to reduce it. How we can reduce it? Obviously, the idea would be to segregate the traffic. If you send a specific unified traffic to a particular server, the objects, Java objects that created there will be approximately the same size, so fragmentation will be low. So how you do it? You group WebLogic servers into individual pools, and those individual pools will process somewhat homogeneous traffic, and it will end up with low JVM heap fragmentation. However, this creates a problem with HTTP session stickiness. So just imagine if your transaction started at one server, and then during the transaction is going on, it end up on a different server. The HTTP session that was created on the first one will not be on the second. So the system will generate errors and will have to recreate the session. And again, you'll end up with a brand new problem there with missing HTTP sessions. So to solve that issue, you have to centralize HTTP session storage. And Coherence Web does exactly that. So Coherence Web stores HTTP sessions on the application grid, which is accessible by every WebLogic server in a cluster. So regardless of where is your transaction at the moment, it will access HTTP session from the grid. So that solves the problem. So with Coherence Web, you will have minimal JVM fragmentation, and there is no problem with HTTP session stickiness. The kind of a bonus for this solution is that you can further segregate the traffic. For example, if you have people in your virtual events that generate certain size of objects, and you have another group of people that are running reports, and their objects will be substantially larger, you can move that particular traffic into a separate cluster. You can create this cluster, and load balancer will send this traffic to this utility, let's say utility cluster. But as long as this utility cluster shares the same Coherence Web layer as your main cluster, it will be able to access the same HTTP sessions. So even if transaction move from one cluster into another, for users it is completely transparent. You can tune WebLogic servers and tune your clusters much better this way. So your performance will be improved even further. And you can the other thing you can basically size your effective cluster this way. You can add or remove clusters in real time with total transparency for users, and it will have no service interruptions, and nobody will even feel that their transaction is now in completely different cluster than it was initially. The solution number two for a problem that we have to switch from a primary into a backup gets solved the same way. As long as you have coherence web layer shared between these two clusters, switch from one into another will be transparent. Because HTTP sessions are accessible from any member of the grid. So now what's happening, coherence becomes a centerpiece of ON24 middleware infrastructure, and it becomes a very important piece. So as such, you have to be able to monitor load. You need to be able to monitor utilization in the coherence system. If something happens, you need to see what if there's. You need to be able to receive some alerts, and to better tune it and better understand, you have to maintain historical data. So, what is the best coherence monitoring solution? Actually, I do strongly believe that the best one is RTView by SL. RTView is a great product, and it's definitely a leader in coherence monitoring. So on this note, I'm going to switch to Tom, who will tell you more about.
Yeah, hi there. Thanks, Alex. I need to share my desktop here. There we go. Okay. So thanks, Alex. We started working with Alex a year or more now, and as Alex described, the challenge was around understanding what is going on in the coherent system, and that happens to be our area of specialty. SL Corporation has been doing applications for monitoring and achieving visibility into critical applications for many years, and we've developed quite an expertise around coherence and also WebLogic and many other middleware technologies. We were, in fact, the first vendor to provide a monitoring tool for coherence. That was way back in 2007, and ever since then we've been perfecting the solution, adding features and capabilities, and most of all, understanding the kinds of problems that people encounter when they're using coherence, much like Alex just described. So in many of these cases, it's a very critical application, and having a good monitoring capability in place assures the availability and the performance of a system based around coherence. As a result of developing this expertise, we have also maintained a very close relationship with the Oracle development people, the support groups, and also the salespeople as well. They often bring us into situations where monitoring is required for coherence. Over this past 4 or 5 years, RTView has in fact become what is considered the de facto standard for monitoring large or complex coherence clusters. So we've got a tremendous customer base in financial services and e-commerce. These are areas where we do see coherence being used a lot. Other market segments like telecommunications, energy, and many others as well. The RTView solution actually has a couple levels to it, and we characterize it as a application performance monitoring solution. Now, in some ways, it's broader than that. It's we think of it as availability, system availability and performance monitoring the critical applications. And here you can see a number of our customers who have very critical applications that run their business. For example, OCL has a worldwide shipment tracking system, and this is based on a number of middleware products that involve Oracle and other middleware vendors. Similarly, Harrah's, or now Caesars Casinos, Intuit uses a lot of middleware components. And so middleware has become an area where we have developed a particular expertise. Now, the application monitoring solutions that we provide come in two flavors. One is a very custom type thing, like many of these things you see here are configured and customized specifically in a user's environment. We also have a great deal of out-of-the-box capability that allows you to aggregate metrics across different type of solutions. Now, in the area of coherence, here's what we encounter. We find that coherence is often used in some kind of an SOA environment, service-oriented environment, where there are applications that invoke various business processes, and underneath you have some sort of a caching system, which is basically augmenting the data layer. So the caching system in coherence provides a very effective means to speed up data access, or in the ON24 case, the session caching, so that you can switch between different sets of user-facing servers, and these are all key features that coherence provides for users in critical applications. Now, with RTView, we have a couple levels. I mean, there are two basic levels. There's this, what we think of as a unified real-time display of data coming from all the different application tiers, meaning we can bring in data that is exposed by JMX beans, by log files at the application level, and then correlate that in some way with the in-depth monitoring that we provide around coherence. So we're going to focus a little bit about the in-depth monitoring of the coherence infrastructure, because that's what we dealt with at ON24. Now, when I first showed up at the ON24 offices, a couple of us went over there, and Alex and his team there had already done a tremendous amount of monitoring themselves. They developed quite an impressive WebLogic monitoring system, all homegrown. They have tons of charts and graphs. They can see everything that's going on in the WebLogic cluster with this homegrown solution that they put together. It was quite impressive, a big wall screen with all sorts of graphs and charts, and they use this on a regular basis, especially during critical times, to understand what's going on in their system. Now, once they introduced coherence, the system became a little bit more complex, and in fact, we see this with many customers who are introducing coherence, is that it's a black box. And what happens is, even though it's a very, very powerful solution, it is a very complicated solution with a lot of functionality inside that is hard to understand. Now, it does expose JMX beans, and you can, if you want to take the time, go in and write your own little JMX monitor collectors, but it's a very challenging exercise, which we'll see. Basically, when you have a black box like this, some questions emerge very quickly. For example, how do you know that it's even working? It may be running, the processes are running, but is it really functioning the way it's supposed to? And even more importantly, is it fast enough? Maybe you can do some rough estimates that it appears like it's caching the database in a way that is providing some improvement, but is it a factor of 2 or is it a factor of 50? And depending on how you tune a system like this, that's the difference that you may encounter. So is it fast enough? And then, even more importantly, what happens when something goes wrong? How do I know what went wrong, and how do I fix it? What do I do to actually repair the situation? So a big black box like this is very difficult to answer these questions. Now, there are some fundamental differences with monitoring something like a coherence cluster in contrast to something like WebLogic. For example, the coherence cluster is a different sort of cluster than a WebLogic cluster. Typically, a WebLogic cluster is, we think of it as a whole bunch of systems operating in parallel, and yeah, they do load balancing. You can direct different users to particular servers, but for the most part, they're operating independently. If one has got some kind of performance issue, or if one of the systems goes down, the load balancer switches to another one, and that's fine. But coherence is different. Coherence fundamentally operates as a whole. So in other words, even though you may have 20 individual servers contributing to your coherence cluster, those individual servers are tied together using the coherence logic in such a way that you really only see one big cluster. You don't see those individual servers that make it up. So it definitely functions differently. It functions as a whole. And there's a sort of internal load balancing that goes on. It's not an external load balancing. So again, this internal load balancing is important, but it's very difficult to see unless you probe inside and try to understand what's going on. The other thing is that the clients actually join the cluster. So a WebLogic server in this picture at the top, in order to use the Coherence cluster, it has to join the cluster itself. It becomes a member of that cluster. And as a result, now the WebLogic server itself starts to become an important contributor to potential performance issues and so on. So to understand how all this works together requires a different kind of monitoring than you might see for a typical WebLogic server farm. So with RTView, we created a product called Oracle Coherence Monitor. This was started in 2007, and the primary goal here was to provide some rich graphics displays that show the cluster as a whole. So in a picture like this, you can see at the top here, just a very simple concept. Over on the left, we have a view of all of the caches that exist within this particular demo system. So this is the size of the box on the left here represents the total number of objects that are in that cluster or the memory utilization for that particular cache in the cluster. And then the color represents the level of activity. So at a glance, this gives you a look at what's going on in the cluster. But what's key is that these boxes don't represent any individual server. They represent the aggregate of the data which has been distributed across the entire cluster. Now over on the right, we see how the data is distributed. So in a coherence cluster, you have processing nodes or client nodes that connect into the cluster, and you have storage nodes. So this view here shows the way in which the data are distributed across the individual storage nodes in the cluster. So the box on the left is a certain way of slicing the data such that we're aggregating for a particular cluster, for a particular cache, like foo, has 350,000 objects, but those 350,000 objects are scattered across all of these individual storage nodes. So what happens is, a view like this gives you, at a glance, a summary from two different dimensions of what's going on in that cluster. And then at the bottom, we also have a very sophisticated alerting mechanism where we can put many different kinds of alerts. We've identified 20 or more different alert scenarios that indicate some kind of potential problem in the cluster that you want to be notified about. So as a whole, the OCM provides these high-level views. Now, here's another view. This is a bar chart view where we look at each of the individual caches, but we look at the aggregate level of activity on that particular cache. So here you can see which caches are having the highest number of misses and hits and puts into the cache. And this becomes a very critical and useful tool to understand where the activity is occurring in your cluster. But again, these are aggregate metrics. There's no notion of individual servers here. It's added up across all the different storage servers in the cluster. Now here's an interesting view. This is something that we use very often. It's one of our most effective ways of looking at data in a coherence cluster. This is what we call a history heat map, where effectively you're looking at the internal load balancing over time. And so on the right, the metrics are new, and then this thing shifts to the left, so it's like a rolling script chart. And so on the right, you see the activity being recorded in the cluster as activity happens. So in this example here, this is an interesting case where we put the OCM into a customer site, and the developers insisted that there was a certain level of activity on particular caches. In this case, each strip represents a certain client of the cluster. And we were running some tests, and what we did is we on their website, which was an online store, we went ahead and did some tests where we would bring up certain pages, and when you mouse over these displays, they show the total number of hits and misses and so on. And we mouse over this little darker green square here, and we found that there was something like 24,000 hits on the cache just to bring up a page showing some number of shoes that were for sale. And the developers insisted that no, that can't possibly be the case. And we said, well, basically the OCM doesn't lie to you. It's telling you there's 24,000 hits going on. And sure enough, once they started digging in their code, they found that they were very inefficiently accessing the cache with gets instead of get all, and it was putting excessive load on the cluster. So these are things that we find even in a development scenario, not only in production, where having this kind of visibility view allows you to understand what's going on inside the cluster and make corrections and improve your performance. Now down at the bottom, this was another one that surprised them. This is a 15-minute span, and the bottom represents the storage nodes. And in this case, every 15 minutes there was this level of activity across all the clusters. Now this little broken line here represents the fact that some of the cache server being hit initially, and then others were being hit the query interval, the next query interval. But basically, this was a surprise to them as well. It turned out there was some rogue process that was accessing and actually inserting data into the cluster that wasn't expected every 15 minutes. So these are all things that views like this can help you discover. So in a system like this, we're looking at the WebLogic clients at the top, the cache servers at the bottom. And then we have other ways. I mean, here's another aggregate view. In a coherence cluster, one of the things we find is that the cluster is highly dependent on communication between cluster nodes. So we track very carefully receiver and publisher failure rates. In other words, when nodes are trying to communicate with one another, this is all hidden inside the cluster. Users never see this. But that communication is critical. And so we track the packet loss. And often what happens is when there is excessive load on the cluster, the packet loss tends to go way up. Here we're seeing a couple of spikes where packet loss was being increased up to 15 or even 20% packet loss. That means 1 out of every 5 packets are being failed to be received by the receiver. And this is often a precursor to some kind of breakdown in the system. So we generate alerts on these things. So here's an example of just some of the alerts. There's about 25 of them, I believe. Available memory, low across the cluster, an average on a per node basis. There's an average of communication across the cluster or across each node. We also measure the capacity, the limit of the caches themselves. So that's coherence. We introduced a lot of this kind of monitoring of coherence within the ON24 environment, and it gives them a certain level of assurance that their system is performing, and it gives them an ability to help tune the performance. Now, in RTView, we've extended the solution. We do have a very powerful WebLogic solution as well, which we are in the process of introducing and enhancing some of the existing WebLogic monitoring capabilities that ON24 had put in place themselves. Another key is that WebLogic uses coherence in a special way. There's a component in WebLogic called Coherence Web. This is a out-of-the-box solution which ON24 is using, which makes use of coherence to store WebLogic user sessions. And these sessions go into this special set of caches. So as a part of our solution that combines coherence and WebLogic, we have some displays that also provide important information about what's going on in the Coherence web caches, there are some additional MBeans that provide information that we bring into RTView and then can alert on as well. So that's a quick overview of the RTView Coherence capabilities and WebLogic capabilities. And with that, I'll turn it back over to Alex.
Okay. Thank you, Tom. Let me share my desktop.
I think you'll have to make Alex the presenter again.
Yeah.
He is.
Okay, give me a second. Can you see my slides?
No, you're not sharing your slides right now. But you are the presenter.
Okay, hold on. Let me see if I can. Okay, sure. 1 second. Okay. Okay. Can you see it now?
Yes, we can. Thank you.
Okay. So, the summary for ON24 solution for quality of service, obviously with both Coherence Web and RTView monitoring, we got substantially higher return on investment. Particularly, we got much better, improved scalability. With Coherence comprehensive monitoring that now encompasses not only WebLogic Server, but Coherence as well. We have no service interruptions. We have less costly maintenance. We don't have to schedule people to work off hours or on weekends. And we have much higher customer satisfaction. With that, obviously we got better customer retention. And what are the next? What are the future directions that we are planning? First of all, as soon as RTView monitoring for WebLogic will be fully released, we're going to implement it, and we're going to monitor both WebLogic and Coherence in one tool rather than a couple of them. This will give us centralized monitoring solution, ability to correlate events and transactions. And the next thing, we will be moving into Coherence path serialization. Path serialization is a very powerful mechanism. It's much more efficient than serialization mechanism built into Java. In my performance testing, at least 6-8 times faster than Java serialization, which will obviously have a positive effect on application performance. The next, we are planning to implement toppling grid. Toppling grid, it stores JPA objects on the grid. So if you're familiar, toppling is a JPA layer, and when you store JPA objects on a grid, you'll get a smaller footprint in individual WebLogic server, simply because those objects are not there anymore, so you don't have to have larger heaps, JVM heaps. You have a smoother switch between primary and backup clusters, because even we have HTTP sessions shared in Coherence Web between primary and backup cluster, but JPA objects are not, and they will have to be recreated in backup. But with toppling grid, they don't have to. So they will be on a grid and will be available at any moment. And the last is we're planning for Coherence Web with push replication. This will allow to replicate HTTP sessions between data centers. So if in case of disaster we need to switch from one data center to another, it will be somewhat transparent for the users as well. And it will provide service isolation and independence. So these are the future directions that we are planning. And now questions.
Thank you, Alex, and thank you, Tom. I'd like to remind everyone that you can submit any questions via the chat window on the right-hand side of your screen. I don't see any at this time. But I'd like to also point out the slides from today's presentation, as well as a recording of this webinar, will be made available for download. And I'll be sending out a follow-up email with a link to the recording within the next few days. At this time, I don't see any questions, so I guess we can complete the webinar. Thank you again, and have a great day. Thank you.